and share my screen, and we'll come over here. So yes, last week of data mining. Last midterm is over. Hopefully that feels good. Hopefully it continues feeling good after Wednesday. We'll get the grades back on Wednesday, have everything graded for you. Basically, our plan for today, we'll go over the format of the final exam. And there's a handout for today. It's the electronic copy is on our GitHub repo under exams, and then this finalprep.pdf. That's the electronic version. Looks something like this. We'll go over this today, and we'll work a couple of problems. From the final, I will give examples of like what I think of as full credit solutions to the problems. And then on Wednesday, we will go over your last midterm. And that probably won't take us very much time, maybe, I don't know, 20 minutes. So we'll then have about an hour or so where you all can do work a problem, and I will give you feedback on if you had done the problem like that, then your grade would be this, and here's the answers why. So you can get a little bit more practice of what to expect for the final exam. It maybe feels extra nervous doing it in front of everybody in class, but my recommendation would be for people to do that so that you get the practice, but certainly nobody would be required to. If we don't have enough volunteers to do that on Wednesday, then I can work some additional problems myself. But my hope is that Wednesday is basically you all saying that I want to work this problem and practice it, and I will provide feedback on it. And one last, I guess, announcement. Those of you who have not yet signed up for an exam time slot, you should do that so that I know to be in my office and do the exam. Yeah, so again, spend the first part of today going over this final prep note. Before we do that, any questions about anything administrative or otherwise? Question? Yeah.
If we turn in the hard copy of our previous two exams, is it possible to take this back?
Question, yeah. Is it possible to get back copies of the previous exams? They're certainly in my office somewhere. I'm pretty sure I can find them. And so if you just come by my office, I will get them for you. Maybe, yeah, one last thing is that, so class on Wednesday, the first part of it going over the midterm exam, that will be recorded. But then everything else about like students working problems, that would not be recorded. Okay. So again, first part up here, the format of your exam. That, again, in-person, one-on-one oral exam. Two main reasons for that. First one, probably the most important, give you practice for technical interviews. Most classes, especially technical ones, don't have a lot of oral exam sort of stuff, but in terms of getting a job, super important. So I would like to get you that practice. And then part B, turns out also that various education studies have shown that students get better grades on oral exams when classes have oral exams than they would have on written exams. And that if you study for an oral exam, the way that the studying goes causes you to retain the knowledge longer. So lots of good reasons for the oral exam. Probably feels maybe a little bit more nerve-wracking than a traditional written exam. And so we'll talk about today how to, some strategies for dealing with that. And in general, I think, so one of the reasons why I did the true, false, open questions the way I did for the previous exams is that I think those feel really nerve-wracking because if you get it wrong, then that's a lot of points off. But these questions that you'll be doing in front of me, it's not going to be adversarial like that. My goal will be to try to get you as many points as possible. And so there's never going to be like this risk of, oh, I accidentally do something slightly wrong and suddenly all the points disappear and actually get negative points. So it should be hopefully less nerve-wracking than that section on the midterms. 30 points for the exam. And again, whatever your percentage grade is on the exam, that'll, if it is higher than your lowest midterm grade, then it'll replace the lowest midterm grade. So hopefully it will be a good grade boost for people. And again, you're signing up for 60-minute blocks, but my goal is that the final exam will take about 30 minutes per student. So it shouldn't be like you're super rushed to get in, say all the things that you need to say. I should feel, yeah, plenty of time that way. So hopefully that also helps you relax. And if for whatever reason you do need more time, then we can make sure that you have enough time to express your knowledge. Last thing that's I don't know, maybe a harder part about the exam is that you're not going to be able to reference any notes or computer or anything at all during the exam. So I'll talk about here in a little bit exactly what you'll need to memorize. But it's basically all the things for those first two quizzes that I asked you to memorize. I might at some point ask you, say, to define the VC dimension and expect you to write out the definition, or define an irreducible matrix and expect you to write out the definition. So the actual questions, though, there will be 5 questions that I will ask you. The first 4 from your previous midterms. 2 from the midterm 1, 2 from midterm 2, and it'll be just from the true false open sections. So we'll do the exams in my office, and in my office I'll just have copies of these pages of the midterms. They won't have the answers on them, but I just have a 10-sided dice. You'll roll the 10-sided dice, and that will be the selection for your question. So you'll know all the questions in advance. You'll know what the answers to the questions are in advance. You'll just have to present an explanation of why the answer is the way it is, and you'll be graded on the quality of that explanation. So yeah, for full credit, you have to both get the answer correct and, the more important part, explain why that answer is correct. Unlike the true false open, if you get the wrong answer, but you have basically the right reasoning, then you'll get 4 out of 5 points. If the explain why it's correct is the important part here. Yeah, we'll do some examples of these in a little bit, so you can get a sense about what I'll be looking for in these answers. But then the next part down here, the question number 5, a more open-ended sort of interview style question. These are, I know maybe it's a little bit more intimidating because I think the grading scheme for these these 4 questions up here will be very explicit about like what you need to do in order to get a certain grade. This last one down here, a little bit more open-ended, so a little bit more ambiguous, maybe a little bit more subjective on my part, but also much closer to the sort of question you might get asked in the technical interview at a company. Or even while you're just like maybe not actually part of the explicit interview part, but people will be talking about this in more like the social sort of settings, and you'll need to be able to talk about these open-ended sort of things. And so I want to get you practice. Excuse me. This question right here, again, we'll talk about it in detail in a little bit, but it's going to be exactly the same for everybody. You know that this is going to be the exact question right here, and so you can. And I recommend you do this. You prepare your answer in advance, have like your 3 to 4 sentences or 3 to 4 minutes of what you want to talk about, the rough diagrams that you want to draw on the board, the things that you want to write on the board, have that all prepared. And you won't have to like freeze or anything. You won't have to spend a lot of time thinking about this, hopefully. This will actually be this will be the way that we'll start the final exam. This will be your first question, so you know exactly how the exam is going to start. And my hope is that this will be a relatively easy question. It's going to be on the, it's like the midterm 3 stuff here on the most recent material. And so material should be fresh in your mind. You'll know exactly what the question is again. So you can come in, just say your thing, and then that'll be our good start to the rest of the exam. This one right here, it's worth 10 points. The other one's worth 5 points. And this one I'm gonna, based on exactly what you say, I'll ask you various different follow-on questions. I've got a list of some of them right here that I might follow up with. So you make sure that you wanna explicitly prepare for each one of these follow-up questions. But I'm not limiting myself to just these questions. I'm not gonna like sit there and read word for word off of one of these items. I'm gonna tailor the question to exactly what you said in the same way that would happen naturally in more of like an interview setting. That's the format of it. I got some tips listed down here. We'll go over those tips as I actually go over these problems and talk about like what my expectations are for a full credit answer to things. But before we go over the example answers to questions, are there any questions just about the format of the final, what to expect? Sweet. Yeah, great question. So the question is, where we're going to discuss the extra credit that if you chose to do that. And the answer is we're going to do all the midterm as stated. I'm going to plug it into your final grade. Then I'll tell you what your final grade is. If you did the Val-Pow-Wabbit extra credit, you'll say, also I did the Val-Pow-Wabbit extra credit after all the final exam stuff is done. And we'll talk about that for a minute or two. And then I'll give you what your final grade, both on the exam and on the course overall, is while you're there in the office with me. And so if you have any questions about that, then you'll be able to ask them right then. I know, yeah, so a quick aside about like rounding of grades. The main reason why I added this extra credit is that if somebody's on a borderline grade and they choose to do the extra credit, that's going to be the thing that will bump like in 89.5 into the 90 category, going from the B+ to an A-. So other than, yeah, whatever the grade is, by that number, that's what we're going to go by. And there's not going to be like, oh, it's 89.999. That's still going to be a B+. But I think that 2 points extra credit's pretty generous. And so that 89.99 is really like an 87.99. So pretty solidly in the B+ category. Another question?
Yeah, and then also because we turned that in before midterm 3, if there was stuff like after we did midterm 3 that we realized could change our code essentially, can we go with that one, or do you have to go with calculation?
Yeah, so the question is, the Val-Pow-Wabbit's already submitted. What if I want to change what I did? Or what if I didn't submit the extra credit, but I want to submit it now? Then it'll just be in the final, you tell me, like, I'm just going to go by what you tell me is a good solution for Val-Pow-Wabbit, and we'll talk about it. So you feel free to adjust what you've already done to, if it's something easier for you to explain or you think it's better for whatever reason. Good questions. Any other questions about anything sort of administrative or anything like that? Ready?
Is it just going to be just the true false question?
Question is it just going to be the true false questions, not the open-ended questions? And yes. So I considered making a larger question pool using both the open-ended questions and then all like the practice questions from the various sources, but we'll simplify things. It'll be just those 10 true false questions that you'll have to think about. And actually, for the very first midterm, I crossed out question 4 right here. So you're also not responsible for that. So there's only even 9 questions on the first midterm. If you happen to roll a 4 on your dice, then we'll just re-roll it.
Okay. Thank you.
Yep. Any other administrative questions?
So I'm just trying to figure out that. So there's 3 midterms, 4 true false questions, right?
2 midterms that you'll be tested on the true false.
Oh, first 2?
Only the first 2.
Oh, okay.
The third midterm will be tested through the that open-ended question. So yeah, you'll have exactly 2 questions from midterm 1 on PageRank, exactly 2 questions, midterm 2 on like the technical details of VC dimension stuff, and then the open-ended question on the most recent material. I think the most recent material is the most important. It's the stuff that you're most likely to be talking about with people at a technical interview. So that's why that's the one that's in this more open-ended format. And also, since the other stuff is less recent, having the more clear grading criteria will help studying. Okay, so let's talk about the midterm 1. What are the key things here to know about? And I'll explain some of these problems. For my rough sort of like thought about time frame is that roughly we'll spend 1 point or 1 minute per point talking about a question. So each one of these true, false, open questions, you should expect to spend roughly 5 minutes or so where we'll talk about it. A full credit answer does not need to spend 5 minutes. I think for most of these, a full credit answer could happen in under a minute. And if you do that, then we'll just move on and things can progress very quickly. But I'm expecting, like on average, students will spend about 5 minutes per question of us talking about it. And so this first one here, problem number 1, if you happen to roll number 1, or whatever you roll, the first thing to do is just to read the question out loud. So let A and B be dense n by n matrices, then the fastest possible algorithm for computing the matrix product A times B has runtime omega n squared log squared n. Since you're reading these things out loud, it'll be important to make sure that you know how to pronounce all of the things in all of the questions, like these omegas and O's and thetas. If there's various mathematical operations, like this would be a cubed right here for problem number 2 is how you'd read that. It's fine on something like n and z to just pronounce it as n and z, or to say the full what it stands for, the number of non-zeros. If you do just say n and z, I might ask you, what does n and z stand for? The number of non-zeros. But yeah, you should make sure that you're able to pronounce everything in all of the questions, and that you don't want to be stumbling on that right when you start up your problem. As you're reading those out, it's good to, let's see, I'm gonna come over here. This will be my rough approximation of a whiteboard here. And it's good to just be taking notes on the whiteboard about exactly what the problem's asking as you're writing things out. So here the problem was saying that you have 2 matrices, A comma B, and they're both n by n. So that's what I would write on the whiteboard as I read that first sentence there, or as I read this first part of the sentence, or I might read it, then pause and write that information on the whiteboard. And it says the fastest possible algorithm for computing the matrix product AB has runtime omega n squared log squared n. So back to my whiteboard here, I'll say that what we're looking for is the fastest possible runtime, of A times B. And then say, is it omega n squared log squared n? And so I've basically rewritten the problem statement on the whiteboard at this point. And but I've done it in a way that's going to be hopefully organize my thoughts a little bit better. As I'm reading it and writing these things out, I'll be able to just think about what's going on, and you don't have to immediately come to the right conclusion, right answer about anything. But this gives you 20 or 30 seconds or so to calm yourself down and think about things without seeming like you're not doing anything. And then after you write out the problem statement like this, my recommendation is that you switch colors on the whiteboard marker that you're using. I'll have several colors available for you to choose from, and this will help you keep things organized, both for your own thought process and for like my own thought process, that your goal again is to convince me that you know what you're talking about. And so I'm not going to be explicitly grading your presentation about anything. But the more that you keep things organized on the whiteboard, the easier it will be for me to find reasons to give you credit for the various problems. And so after you sort of write the problem, then the next thing to do is to write out, what do we know? You don't have to explicitly write out this phrase right here, but you can if you want. If you want to buy time, or if you feel like you're nervous and just want very clear structure to each of your problems, then you can just, what do we know? And in this case, there's two things that we know about matrix multiplication. We know a lower bound. The lower bound was omega of n squared log n, like this. And this lower bound is something that I am expecting you to just know. You're not going to have access to your notes or to a computer to look this up, but I'm expecting you to just know. And similarly, we have the upper bound of O of, you don't have to know this precisely, exactly, but something, you just say, I think it's roughly like this. It's very low in the power of 2. But if you had to say something like, I think this is the decimal expansion, but I'm drawing a blank right now, and so I'd have to look up the exact numbers, that's a totally okay thing to do. If you totally blank on something, like say, oh, I know there's a lower bound, but I just totally forget what it is, you can ask me what it is and I'll tell you, and it'll be a very small point deduction on the problem. So yeah, if you totally blank, not the end of the world. You can always ask me for help, and I will try to steer you back on the right track for the problem. And so then after you write what do we know, then the last part is just combining this information together in order to come up with the right solution for the particular problem. So in this case, the important thing here is you'd have to identify that this log squared of n, this squared right here, is important. And so asymptotically, we know that n squared log squared n is greater than n squared log n. And this would be something that you could just state out loud or write it down. In general, I think the more things you write on the whiteboard, the easier it is to communicate your ideas and make sure that I'm fully understanding what you're saying. That if you write this down, then I know exactly which thing you think is greater than the other thing. But if you're just talking without writing something down, it's very easy, especially when you're nervous, to say something backwards and then think you made a mistake. But if you write it down, then I'll know exactly what you mean. And you say that since this is the best thing that we know about it, it's the most strict thing that we can say, and this thing is greater than this up here, then it's potentially an open problem, that this would be bigger than the known lower bound. Also, going the other way, with the known upper bound, the n squared log squared n is less than the polynomial that we have up there, n to the 2.231. And again, at this point, I would say something like, it doesn't even matter exactly what this decimal expansion over here is, that any polynomial is bigger than any logarithmic factor. And so even though I might have forgotten exactly what this decimal expansion is, I still know it must be greater than this n squared log squared n. And this tells me that what the problem is asking sits between these two pieces of knowledge that we already have about the lower bound, the best lower bound we have, and the best upper bound we have. And so it must be an open problem. And again, I recommend explicitly writing down on the board what you are claiming the answer to be. That way there can be no miscommunication where I don't understand what you're trying to say. Is there any questions on any of that so far, either the actual technical content or the sort of meta problem of explaining the contents? Does this feel like something that you all feel like, yeah, go ahead. Check.
So if you give a time that's in between best and or like what's known to be lower bound, what's known to be upper bound, then it's open. If it's above the upper bound, but it's below that lower bound, then it's pretty fast.
That's correct. Yeah. And yeah, so that leads me into the next part about this problem, that depending on exactly how you work through the true and false question and exactly what you explain, if I feel like the explanation you gave makes me 100% confident that you know the material, then you'll just get 5 out of 5 on the question, and we'll move on to the next problem. If I'm not 100% confident, that's 100% okay. You're not going to lose points. I'll just ask a follow-on question asking you to clarify something, either to clarify like what you've written down. Maybe you accidentally wrote one of these less thans and greater thans in the wrong direction, in which case I'll ask you to just clarify if you actually mean what you wrote up there. Maybe I'm misunderstanding something. Or I might ask you to modify the problem somewhat. Like I might say, okay, what if instead of n squared log squared n, what if we got rid of that? And so that it was just omega of n squared. And have you re-explain the problem based on just that situation. These sorts of clarifying questions, I'm not going to make a major change to the problem in any way. I'm just going to make one small thing and change it. Like if there's a formula, change what the formula is. Or maybe I could say instead of omega right here, maybe it's a theta or an O. Or maybe instead of like an n by n matrix, what if this was an n by m matrix? One small adjustment like that and ask you to clarify based on that, your understanding. And again, I'll do that if your previous explanation, depending on what the previous explanation was. Any questions about that? Okay. So let's do another example problem here from this first midterm. And let's take a look at this. Every stochastic matrix is irreducible problem. Number 7 down here. So this problem is small enough that when you're rewriting the problem statement, just stating it exactly as it is. Where did my cursor go to? My pad here has gotten disconnected for some reason. There we go. So I think it said every stochastic matrix is irreducible. So again, on this problem, the first thing to do after you write out what the problem is asking for, write out what are the things that we know. And in this case, there's two important things to talk about. What is this stochastic matrix and what is irreducibility? In this case, come back over here. This was the answer sheet to our quiz here. If you provide an exact definition from the answer sheet, then that's an okay thing to do. Or if your definition is more intuitive, that's an okay thing to do. But somehow you have to be able to convince me that you know what an irreducible matrix is. So the graph that shows that every node is reachable from every other node. And here in this case, actually, the stochastic matrix is not something that I explicitly asked you to memorize down here. But if you don't know what a stochastic matrix is, you're not going to be able to answer this problem. So that is also something that you'll need to know for the midterm, or sorry, for the final. And so we'll just start saying, okay, the stochastic matrix, okay to do abbreviations while you're writing on the whiteboard if you would like to. Just make sure that you tell me verbally what those abbreviations are meaning. This is going to mean that the rows sum to 1 and the entries are non-negative. Non-negative. I would also add that the intuition behind this is that each entry in the row is like a probability and the row is like a probability distribution. But you don't have to write out everything that you say. I would just write out the definition and then say that in words, that like the intuition is that the row is a probability distribution and each entry is the actual probability of being at that particular node. And then an irreducible matrix, irreducible matrix. We said already that the graph is reachable no matter, or the graph that corresponds to the matrix means that every node is reachable from every other node. Or implies is a nicer word to use right here. You notice, yeah, so I'm using the little notepad right here. So it's easy to record and pick up on Zoom. But when you're working on the whiteboard, if you do write something that you're not happy with, then you should actually erase it and rewrite what you intended to write. Don't just scribble things out so that the final product is as neat as possible. Again, you won't lose points if you scribble something out, but the cleaner your presentation is, the easier it will be for me to follow what you're saying, and the easier it is for me to be confident you know what you're talking about. So I'll give you more points. So the graph corresponds to the matrix, implies every node reachable from every other node. And at this point, if I were explaining this, these definitions right here would feel a little bit abstract. And so I would give a quick example of what I mean by the graph that in PageRank we have nodes and edges between them. Something like this, maybe. So I'm giving a quick example right here. There's a little meta note. I wouldn't write up here that I'm giving an example. But maybe actually just writing the word example would help organize thoughts. And then the P matrix is 4 by 4, and each node corresponds to one of the rows or columns. The more that you sort of preemptively talk about these sorts of things, the less likely I will be to ask follow-up questions. And so the more you preemptively choose what things to talk about, the more you have a chance to ensure that the things that you're talking about are things that you know about. If I ask questions, I might ask a question about something that you're less prepared to talk about. And so it's you can have more control over the topics that get covered this way. Each node corresponds to a row or column in the matrix. And then P sub ij is the probability of transition from I to j. And so basically, actually right here, I defined the P matrix with this example, and not required for the problem, not required for full credit, but it illustrates a more complete understanding of the problem and something that I might have asked on a follow-up question anyways. And now, question is, every stochastic matrix, is every stochastic matrix irreducible? So the actual solution here, we have to come up with the counterexample of a stochastic matrix that is not irreducible. And the easy way to do that, the one that I have sort of in my back pocket all the time, is just every node linking to itself. Then the P matrix would be 1, 1, 1, 1. That's supposed to be a 1 right there. Zeros everywhere else. And that matrix is clearly stochastic by our definition above, but also clearly not irreducible. If you look at this graph, you can't reach any other node from any other node. So because of that, the counterexample implies that the answer must be false. Are there any questions about that, either in terms of the technical content or the, I guess, more meta strategies? Okay. So what are some possible follow-up questions that I might ask to something like this? Anytime there's a definition like stochastic matrix or irreducible, I might just say substitute the words irreducible up here for primitive. So if we crossed out irreducible and put the word primitive, then is the question still true, or sorry, is the question still false, or has it now become true? And in this case, so now you have to know what is a primitive matrix. And the important thing to know about it is that every primitive matrix is an irreducible matrix. The only difference is that it has one eigenvalue on its spectral circle. So we know that this matrix, this example matrix that I have down here, was already irreducible. The question is it primitive? And the answer is, it is the largest eigenvalue. So the primitive matrix has exactly one eigenvalue on its spectral circle. The eigenvalues here are 1 with the multiplicity of 4. That it's an identity matrix. The largest eigenvalue is also the smallest eigenvalue is also 1. And so now in order to say whether this is going to be false, then we know that this is now false because this is not only was it not irreducible, but the eigenvalues are there's more than one eigenvalue on the spectral circle. So we're still with the answer of false. Any questions? Yes. Yeah, the question is, so here it must be irreducible and it must be have the eigenvalue situation. It would be enough to only talk about the irreducibility, said that we already know that it doesn't have to be irreducible. So if it doesn't have to be irreducible, it also doesn't have to be primitive. That would be it would be enough to stop there, or it'd be enough to keep going and talking about the eigenvalues. Okay, I want to go back to our notes here, just go over these little tips at the end here, and then we'll go back over that sort of open-ended question. So again, I mentioned a lot of these things as we were doing those first two problems, but I also want to just make sure that we talk about all of these here. So the first tip, I think the most important one, is you know what the first question is going to be. You know exactly how the final is going to start off. So you should prepare an answer in advance for this open-ended question and actually practice saying it and writing your response to other students in the class up at a whiteboard, so that you're not it's not your first time doing that when you get to the final exam. And for the other questions, it's probably too much to practice going over all of them in person with people, but I'd recommend doing some of those in person. And you're welcome to actually write out or prepare your responses for all of those, so that you know, no matter what the dice come up, you've prepared for it. One of the main, I think, reasons people get nervous for these sort of final exams is the idea that you might panic and not know what to say. And so I just have a list of strategies down here of good things tools to keep in your pocket about how to buy time so it doesn't look like you don't know what you have to say. So again, reading the question out loud, I just recommend doing that all the time, giving yourself that extra little bit to think about things and making sure that we're both on the same page, talking about the same question. Again, as you're reading it, writing down the key information on the whiteboard, that'll help you jog your memory about what are the right things to say. And then, so this find a keyword in the prompt that you know and say something about that. So that was that step 2 of writing out the definitions of everything that you see, all the things that we know. Just pick one at a time and say something about that. A little I don't know, small trick here, number D. If you just need to buy 5 seconds, just nobody's going to think it's weird if you set down your whiteboard marker and pick up a new one. It will seem weird if you just stand there for 5 seconds, staring off into the air. But if you're doing something that seems like a reasonable thing to do, then I'm not going to think, oh, they don't know what they're thinking right now. They're being really artsy with their presentation. I like that. So similarly, like bringing other sort of props, like a water bottle that can just be something to distract yourself, give yourself a little chance to have a minute or two to think, a couple or a second or two to think without it feeling obvious like that. But it's also okay to say like okay, you've read out the question for a second and you've written down what you need to know, and then just saying, I'm gonna think about for a second now, what are the things that we know about this problem? And as long as you told me what you're thinking about, then it's not weird if you just sit for like 5 or 10 seconds and think. It'll become weird if it's like 2 minutes and you haven't said anything, but like 10 seconds, it's not weird. It'll be weird if you don't tell me why you're not talking. But if you just say like, okay, I'm going to think about that for a second, and you think, then it's not going to feel weird on my end, and I'm not going to think you don't know what you're talking about. So it's always a fine backup thing. Don't feel bad if you use that. And then again, I didn't like write it here, but also you always have the backup option of like just specifically asking like I'm drawing a blank on the definition of this thing and asking for like a pointer on how to continue. And again, the grading on this is intended to not be harsh like it was on the midterms. So this is not like, oh, you ask for a tip and then you get a 0. It'll be like very minor thing, especially, and if you can like recover from that, explain everything else, then it might not even be a point off. So yeah, perfectly natural to I don't know, ask in like an interview situation to ask the person interviewing you for like a tip on how to proceed. So I like this term boardsmanship about keeping your board area clean. The maybe a little like meta thing too, that in a classroom setting, I've never done oral exams before. But before this, I was a naval officer working on nuclear power plants. Everything, when people are qualifying to do different things on nuclear power plants, it's all done on a whiteboard and like these technical interview sessions. And so everybody in the Navy is always talking about their boardsmanship. Like how well can you use a board, just like their seamanship, how well they can navigate the sea. So that's where the term comes from. And again, not explicitly graded, but the more you keep the board nice, the easier it will be for me to find things to award you credit for. So again, like writing things for every one of the problems, just find something to put on the board. There's no need to write fast, and usually writing slowly will help calm your nerves. One of the common failure modes of people doing interviews or these oral exams for the first time is saying things too fast because you're nervous. So writing slowly, practice writing slowly will help with that. Another sort of failure mode, if you write things too small and I can't read it and I'm constantly asking you to like, what does this say? That will make it harder for me to award points. So I think about like writing a capital letter should be about 3 inches tall on the blackboard, on the whiteboard. So my eyesight is actually quite good, but when you're in an interview session, the people who are doing the interviewing are usually about twice as old as the people being interviewed, and old people have bad eyes and can't see well. And so big writing always helpful there. Also, in terms of like writing resumes for places, the people who are reading resumes always have bad eyes, and using a font like 14 point or 15 or 16 point even is always appreciated by them. Big fonts always get more well looked at. So again, colors, differentiating part of your answers. I was doing that over here in these these examples, trying to clearly differentiate what are the things that were given in the problem, what are the things that are still basically given, but they're things that I know in my head from my background knowledge about the problem. And so that if I see that this stuff in red here is different color, then it's just easy to say, oh, there's a lot of red on that board. This person knows a lot and they should get lots of credit for this problem. And I don't even have to like read actually what the text says. I can just see, wow, there's a lot of things up there. Oops, where am I going? There we go. If you're drawing any figures, which we'll be doing in that open-ended problem, using different colors to exactly make it clear what's going on, you should definitely do that. And if you have, so yeah, the previous problems, multiple definitions, I use the same color for each definition, but somehow making it clear where the definitions are different from each other. I made it clear here, they're different through like indentation, but doing different colors would also be a clear formatting way here. Another sort of slow things down tip and calm your nerves is between all the problems, totally erase the whiteboard. Again, that's good so that when you get to the next problem, you can just immediately start showing off your knowledge. But this will help slow things down, so definitely do this. And this part G here, I think is going to be the hardest thing of these tips to do, but you should really try to work on it, is that as you're writing, you should be talking about things. That way, I don't know, it's clear in my mind or in a future interviewer's mind, wow, this person must really know what they're talking about if they can multitask this way. And it's there's no like pause in the flow of conversations. So I, especially on this first open-ended problem where you know exactly what it's going to be, practice talking and writing in a way that feels natural. It's okay if you say something like, there's a complicated thing that I have to write here, so I'm just going to write it out and then explain it later. And then maybe there's a 30-second pause where you're just writing and not saying anything. But again, if you're pausing for a long period of time like that, you should explain why you're pausing. It's okay to pause even for long periods of time. Just before doing that, explain why you're pausing. So I'm going to pause for a second to think about this, or I'm going to pause for a second to write this complex thing on the board. Something like that. Again, not good to just not be talking for a long time, even if you're writing without saying anything. Yeah, and then, so content-wise, ensure you've memorized all the definitions from the quizzes. Any problem, if there's a definition that's related, I might ask you to just provide the definition, or it'll be obvious that you have to provide that definition. And then very last thing, again, Wednesday, first part of the class, review of the midterm 3, and then you'll have the chance to practice this up here on the front, and I'll give you immediate feedback and say that if you did this, answered the question that way on the final exam, you'd be full credit answer, or you need to explain these other things in order to get full credit. Okay, so we're gonna, in a minute here, go to the open-ended question. But before we do that, any questions about anything? Okay.
Ask about like whether or not an identity matrix is related to this. We talked about
So the question is a technical question about primitivity here, whether the top eigen, or sorry, whether an identity matrix is primitive. Is that the question?
Yeah.
The answer is that an identity matrix is not primitive. That was our specific counter example right here, that we had this this identity matrix, and we said that the identity matrix is stochastic, but that it is not primitive. And we had the two reasons for that. The first reason was that it is not irreducible because you can't reach every node. But then you're right that it does have a top eigenvalue of 1, but that top eigenvalue is not unique. And the definition from our paper about primitivity here says that exactly one eigenvalue on its spectral circle. If you write out or say that exactly one eigenvalue on its spectral circle, I will probably ask you to rephrase that. And a more clear rephrasing of that would be that the top eigenvalue is unique. And here the top eigenvalue is not unique.
And then I guess I would follow up to that. So like for number 9 on the term 1, it says it's possible for the p-bar matrix to be primitive, which is true. But we don't have an identity matrix, and we have to calculate the eigenvalues for that. So I'm assuming it'd be a lot harder. I'm supposed to know like how.
Yeah, so yeah, the question is like here, I know what the eigenvalues are automatically because of it's the identity matrix, and I just know what the eigenvalues of an identity matrix are. But what if it's a different matrix? And you are required to know that for the p bar bar matrix, that the so the key thing about this is that it had the alpha times p bar plus 1 minus alpha E transpose over n, something like this, where we're doing a weighted average between these two matrices, and that this is explicitly constructed. Explicitly constructed so that top eigenvalue equals 1 and second eigenvalue is less than or equal to alpha. Happy to explain why this construction does this later. That'll take a little bit more time, but this is the sort of fact that I'm expecting you to know about this p bar bar matrix here and pull it out when appropriate. Does that answer your question?
I can ask.
Okay. Yeah. Lulu? Yeah, so my recommendation is that you prepare, like, I'm going to prepare midterm 2 problem 3, because that one is one that I want to make sure that I get good feedback on for whatever reason. Either I've already prepared it really well, I think I'll do well, or I want to check my understanding of that problem. And then, yeah, then you'll just do that problem that you'd like to do. If you would like me to roll the dice, or you would like to roll the dice and select one, you're welcome to do so as well. Okay, we've got about 15 minutes left, and I want to make sure that we get to the this open-ended question. Go here. So again, this open-ended question is going to be the same for everybody. And the very first question on the exam, I've said that a number of times now, so everybody should have that like burned into your brains. This will be the first thing on your exam, and we'll just come in and you'll know exactly what to expect. So the question itself is, our company is building a content moderation system for a new social media platform. Again, I'm reading the question out loud, so this is sort of like my what I would be doing as I'm first coming into the exam, reading it out loud. And as I get to the parts that seem like they're going to be interesting or relevant to whatever the final solution is, I'll write it on the board. This seems like a, I don't know, just filler at this point. Our company is building content moderation system for a new social media platform. In order to do this, we're building a text classification model that outputs whether the input text is abusive or not. At this point, I might think, okay, that's still just filler about the problem, or I might come down to the Blackboard and say like, so text classification, where the outputs are abusive or not abusive. And either way would be fine, whatever you feel most comfortable with. And then for simplicity, we plan on using a logistic regression model. Anytime problem specifically talking about a model, that's something that you'll definitely want to have up here as background information you can reference. Logistic regression model. And but we're not yet sure what types of features should we use. And we're considering two options, either the one-hot encoding with feature hashing using val-pow-abbott, or word2vec with scikit-learn. So which features either the one-hot encoding with val-pow-abbott or the word2vec with scikit-learn. And now the question is, finally we get to the question, which would you choose and why? And so any of these, so again, this is, I think, a very typical open-ended question of a technical interview that companies talking about what their sort of problems they're facing and asking you at a high level how you would approach those sorts of problems. And so which to use is the actual question. The first thing, the most important thing that we want to consider anytime we're picking one of these data mining problems is, or solving one of these data mining problems is, what is our out of sample error going to be? And you can write it out of sample error, or you can just say E out. If it was like an actual interview situation, I would write out both the, like, whatever the notation that I plan on using to represent this to be. So here, E out's what we've been using all the semester. And I would write out the definition of that in words just to make it 100% clear to whoever's talking to me exactly what I mean by this notation. Because the notation does vary a lot between like whatever textbooks people happen to use when they were learning things. Actual interview situation, good thing to do both things. For the purposes of the final exam, I know like all the notation and stuff. So if you just want to say E out, then that's totally okay. And the way that we always determine the E out is this model complexity graph. So model complexity down here. And then there's the two different factors that go into my E sub out. That we have our E in, training, error. Then you don't have to write out both definitions of things if you don't want to, but I'm doing that here. And we'll just make things, use lots of different colors here, make it nice and pretty. Here, the generalization error, E in minus E out. Generalization error. And the final thing that we're actually interested in looks something like this, the sum of these two, the training error and our generalization error. This is what we're actually interested in. There's some ideal model complexity that we have to figure out what is it going to be. Traditionally, the region on the left of this graph over here is called underfitting. And on the right over here, overfitting. And we're going to determine which of those two models we're going to use based on whether I think we're more likely to be underfitting or overfitting on this particular problem. I know that with val-pow-abbott, for example, with val-pow-abbott, the VC dimension is determined by the size of the hash by the dash dash bit precision. And in practice, this dash dash bit position is usually fairly large. In practice, it's large. The default is 18. And the VC dimension is 2 raised to the bit precision, here BP. So I was a little bit disorganized when I did this, but this is my formula for the VC dimension. And so the default VC dimension here is pretty large. Substituting in 18 for this BP value, then that's almost not quite 1 million. If you can't do the powers of 2 math in your head, that's okay. Just knowing that it's really large is good enough. Switching colors now. So with Word2Vec, here the interesting thing is that the VC dimension is the size of my word vectors. And while the word vectors can theoretically be of any size, practical values are usually very small. And as you're working on your final project of the search engine, you have to look through what a bunch of different models, and you'll see that like 300 is the widely used biggest value. Practical values are like less than or equal to 300. So the VC dimension over here is very small compared to the VC dimension up here. If we have a small amount of training data, well, I know that let me back up for a second. I got ahead of myself for a second. It's okay when you're talking with me in the final exam. If you get ahead of yourself, just say, actually, scratch that. Let me back up for a second. I want to talk about the generalization error now based on VC bounds. I know that the generalization error is O of square root of the VC dimension log n over n. And the way that I'm going to choose which of these 2 models I think might be better is based on how much training data that I have available. If n is really small, if n is very small, then I know val-pow-wabbit can't work. So you could, if you want to pick a particular value for very small, that's fine. You could say like approximately, you'll say 10 to the 4th, for example. Then val-pow-wabbit will have a huge generalization error. But the Word2Vec option will have a small generalization error. And so I will use, in this case, I'll use Word2Vec definitely instead of val-pow-wabbit. It would be fine if you wanted to stop there and then we go into me asking you follow-on questions, or you could keep going and saying that what about in the opposite case? And if it's, yeah, so for the purposes of our final exam, it's fine to talk in a little bit more abstract details like this if you like. If it was actually on an interview question, at this point, you could stop and like ask the interviewer, like, I don't know, in your like particular application, do you have a lot of training data yet? Or is it a small amount of training data? Ask them like exactly what the in value is. It's fine if you want to ask me like that as if I were actually working at this company, then I will answer as if I'm actually working at this company. Or if you want to ask, stay more abstract, that's also okay. Here I'll say, if n is very large, say like, I'll do n equals 10 to the 9th, then I don't think I'm going to be worried about generalization error. I'll be worried about generalization error. But I know that performance will be very critical. I know runtime will be critical. ValPoWabbit has great runtime for large data sets. And so I will probably try that as my first solution. There's lots more things at this point that you could say about all of this. And you can have as much or as little as you want prepared going into the question. At this point, what I've talked about so far would not yet be full credit because if you stopped at this point, I would want to continue asking follow-up questions to probe into the different areas. But this is a good start to getting the full credit response.
In this case, would it be right to say that the big data set, since our GDC for root is so small, we would probably be on it?
Yeah, so that's great question. So the question is, if we have this data set of 1 billion points and our VC dimension is so small, are we likely to be underfitting the data? And then you can say, so what are some solutions that we can do to resolve underfitting? And you can say we can make our model more complicated by, instead of using logistic regression, maybe we'll use a neural network with a large internal layer, or we'll use the polynomial feature map. And that would segue us into a discussion about resolving underfitting issues. So this one in particular, there's like lots and lots of directions that it can go in. Again, I have those sample questions that you should be prepared for going in those different directions. And this will be maybe, hopefully, more get you some real world practice for the way things might go at an interview setting. I think that's a good stopping point for us for today. Again, Wednesday will be directed by you all, so come prepared for that. And yeah, if people have other questions about things, happy to stay after class and talk about them, but that's the end for today.